Okay, now we're doing part D of this fun activity of finding eigenvalues and eigenvectors. So we've got 7, 4, -10, -5, and we're going to find its eigenvalues first. So we're doing determinant of the diagonal minus lambdas for -10, -5 minus lambda equals 0. Solving this equation for lambda. Well, determinant is 7 minus lambda times -5 minus lambda minus the diagonal, but minus the negative, so plus 40 equals 0. So -35 FOIL outside minus 7 lambda plus 5 lambda plus lambda squared plus 40 equals 0. Simplify, so lambda squared minus 7 plus minus 2 lambda, and then plus 5 equals 0. Okay, so now I have, oh boy, I smell trouble. All right, let's do the quadratic formula. Lambda equals -b plus or minus the square root of b squared, so 4 minus 4ac all over 2a. Okay, so lambda equals 2 plus or minus the square root. 4 minus 20 would be -16 all over 2. And then, so lambda equals 2 over 2 is 1 plus or minus. Square root of 16 is 4, but then there's a -1 there, so we call it 4i, where I is the square root of -1. Okay, so now complex numbers. How familiar are you with complex numbers? Well, just know that I is a special number that when you square it, you get -1. Okay, that's all you need to know right now. So we'll do lambda equals 1 plus 4i, and lambda equals 1 minus 4i. Okay. Where do we begin? All right, so at least I don't have any divided by 2 here. Let's count your blessings. All right. So put that in for lambda. So 7 minus this. 7 minus 1 is 6. Minus 4i. And then 4. And then -10. And then -5 minus this is -5 minus this is -6. Minus 4i. xy equals 0, 0. Okay, so these two equations ought to be scalar multiples of each other if we've done our arithmetic correctly, and so they ought to be the same equation. So you can probably pick your favorite. My favorite's the top one, so that's what we'll do. So 6 minus 4i times x plus 4y equals 0. So then let's solve for y. So y equals a negative of that. This would be -6 plus 4i over 4 times x. I can simplify that. -3 plus 2i over 2 times x. Okay, so if x is 2, then y would be -3 plus 2i. So we'll do that. 2, -3 plus 2i. Okay. And then this is the freebie. So whenever you have a complex eigenvector, if your matrix, the original matrix, is all real numbers, and you get complex eigenvalues, so you get complex eigenvectors, and your complex eigenvalues will be reciprocals of each other, 1 plus or minus 4i, and so your eigenvectors will be reciprocals of each other. So I already know this other one will be 2, negative 3, minus 2i. Okay, you get that one for free today. All right, that'll be the end of section D.